Hello, welcome to Numeristical. Today we're continuing our deep dive into the AUC. We are now at part 2, which is giving the graphical definition of the AUC. If you have not yet seen part 1, where we did the introduction and talked about the relevance of AUC for machine learning, I recommend you go back and watch that video now. But for now, this is part 2, where we go into the graphical definition of AUC. And as you probably know by now, the AUC stands for the area under the ROC curve. So the graphical definition of that number just says, we'll plot the ROC curve and then determine the area underneath it. So that sounds pretty straightforward. Now, how do we actually plot this ROC curve? Well, the idea is that for each possible threshold, we're going to calculate the sensitivity and specificity values. And then we're going to plot the point with 1 minus specificity on the x-axis and sensitivity on the y-axis. Now, you might also see this referred to as the false positive rate and the true positive rate. I try to avoid those terms because I think the false positive rate often misleads people. It's a little bit ambiguous in what people think it might mean, and so people often confuse it in their head as to what it really means. So I prefer to stick to 1 minus the specificity. But anyway, once we've done that for each threshold, we just connect the adjacent points and determine the area. And the best way really to see this is to go through an example. So we're going to do that now. And we're going to pick up from where we were in the last video, where we built a fraud detection algorithm. So we imagine that we had a model for fraud detection, and we had a test set of 15 points, and we applied this model to those 15 points, and we got the 15 scores listed here. And then we looked at the true answers, and in this case, 5 of those 15 were fraudulent, and the other 10 were legitimate transactions. So the 5 fraud cases are represented by 1s, the 10 legitimate transactions are represented by 0s. And so to start drawing the ROC curve, first we draw this set of axes with sensitivity on the y-axis and 1 minus specificity on the x-axis. And we also typically draw the line y equals x, and that's as a reference, because if our curve is very close to that line, that usually indicates that we don't really have much predictive power. There's not really a relationship between the scores and the true values. And to start off, we're going to start with the most restrictive threshold. So we're going to start with a threshold that's higher than any point in our test set. And therefore, given that threshold, we're going to declare everything to be legitimate. So what happens in that case? In that case, our sensitivity is 0 out of 5, because there are 5 fraud cases, but we didn't declare any of them to be fraud. But our specificity is 10 out of 10. There were 10 legitimate transactions, and we declared them all to be legitimate. And therefore, our 1 minus specificity is 0, so that leads to the point 0, 0. So this bottom left-hand point of this axis corresponds to sort of the most restrictive threshold, where you just don't declare anything to be a 1, and you guess that everything's a 0. And now, so imagine that threshold was 77 or something like that. As we change it to 76, 75, 74, nothing changes in our sensitivity and specificity values. And therefore, when I say we do this for every threshold, what I really mean is for every threshold, that's going to give you a different sensitivity and specificity pair, because lots of thresholds are going to give you the same answers. So this simplifies our problem, because if you look at it, since we have 15 test points, there's only 16 different thresholds that could give us a different pair of sensitivity and specificity values. So that simplifies the problem a bit. So let's imagine now we bring our threshold down. So once it gets below 73, now something changes, right? Now we've finally declared the one riskiest case to be fraud. And so our sensitivity goes up. It's now 1 out of 5, or 0.2. And our specificity remains the same. We still declared all 10 of the legitimate transactions to be legitimate. And so we get a new point with an x value of 0 and a y value of 0.2. Suppose I lower my threshold again, nothing changes until I get below 66. And then again, now I've caught 2 out of the 5 fraud cases. My sensitivity goes up to 0.4. And my specificity remains at 10 out of 10. And so I get to the point 0, 0.4, because we're plotting 1 minus specificity. Now next, I lower my threshold again. Once I get below 64, now there's a legitimate transaction that I've now declared to be fraud once I've lowered it. So in this case, my sensitivity stays the same, but my specificity actually goes down. I've only labeled 9 out of the 10 legitimate transactions correctly. So I move to the right by a value of 0.1. Continuing again, now another 1 goes above the threshold, and our sensitivity goes up to 3 out of 5, or 0.6, and I plot another point. And one thing I want to point out here is that the scores on the left actually don't matter for this process. It doesn't really matter what those numbers were. It just really matters the order of the 1s and 0s. So I'm actually going to get rid of those numbers and just see how things change as we move this threshold down every time we pass a new value. And you'll notice something as this curve starts drawing is that every time we pass a 0, we go 1 unit to the right, and every time we pass a 1, we go 1 unit up. And a unit in this case is, for the sensitivity, moves in units of 0.2, because there's 5 fraud cases. So our sensitivity is going to move in units of 1/5 or 0.2. And when we move to the right, we're moving in units of 1/10 because there were 10 legitimate transactions. So we're moving in units of 0.1. And so as our threshold goes from the most restrictive to the least restrictive, we're going to take 5 steps vertically of length 1/5 and 10 steps horizontally of length 1/10. And so at the end of this process, we'll have gone from the 0.00 to the 0.11. And all that really changes from different models and different sets of predictions is the ordering of that 1s and 0s. That ordering alone is going to determine the path of our ROC curve and therefore the AUC value. So now we've completed drawing the curve, and the question is, okay, what's the AUC value? I see the curve, I want to know what the value is. Well, another thing to point out is that although we call it an ROC curve, it's actually just a staircase here, right? We can think about this as a set of rectangles. And since we know that we move in vertical increments of 0.2, I'm going to imagine this as 5 rectangles that are horizontal and with differing widths. And so if I break it up in this way, we see the first rectangle, the bottommost one, has an area of 0.2. Same with the second one. They're both height of 0.2 and a width of 1. The third one only has a width of 0.9, so it gets an area of 0.18. The fourth one has a width of 0.7, gets an area of 0.14. And the top one gets an area of 0.4, giving an area of 0.08. And if you add all those up, you're going to get an AUC value of 0.80. And now if you try to think about what does that mean, is that good, is that bad, you'll see some references that might say something like 0.7 to 0.8 is good, 0.8 to 0.9 is very good, above 0.9 is excellent. You'll see some very qualitative descriptions. And most things will make the point that AUC of 1 means perfect prediction, means kind of all your 1s are at the top and all your 0s are at the bottom. And an AUC of 0.5 is around what you would expect if there's really no relationship between those scores and the thing you're trying to predict. So in other words, we just randomly put that string of 1s and 0s and shuffle them up randomly. We'd expect something around 0.5. So this is a little bit unsatisfying, right? We'd like to have a better sense of what does an AUC of 0.8 really mean. And that's going to be the subject of our next video. We're going to really be able to give a nice explicit definition of what this means in terms of taking a random pair of 1s and 0s. And so to start motivating that, I want to point out that there's this notion of a unit rectangle where, since we're only taking steps of 0.2 vertically and 0.1 horizontally, I can think of this unit square as broken up into these unit rectangles. And since they have height of 0.2 and width of 0.1, in this case there are 50 unit rectangles in the unit square, and some of them are under the curve, and some of them are below the curve, and some of them are above the curve. And what we're going to see is that each unit rectangle is going to correspond to a choice of a 1 and the choice of a 0. And that rectangle is going to be under the curve when the 1 ranks higher than the 0. And it's going to be above the curve when the 1 ranks lower than the 0. And so this is going to give us a way to define the AUC in terms of what happens when I randomly pick a positive case and a negative case. Did I rank them correctly or not? And so that's going to be the subject of our next video. So hopefully that whets your appetite a little bit. So please stay tuned for our next video, which will go through this in more detail. Hope you enjoyed this. Please like and subscribe if you can. It really helps me out, especially if you subscribe to the video or to the channel. And thanks for watching. Have a great day.